Whether it's bleaching, overfishing, or pollution, everyone knows that the coral reefs are having a bad time. But what about ocean acidification? Ocean acidification, or OA, affects the growth and general health of coral reefs and many of their associated species. Many scientists predict reefs disappearing by as early as 2050. But hang on, let's rewind a little. What exactly is ocean acidification? And how does it happen? Surprise, surprise, it all comes back down to our good old friend, carbon dioxide.
When CO2 dissolves into water, a chemical reaction takes place. Carbon dioxide and water combine to form carbonic acid. When there is carbonic acid in the water, a couple of things happen. First of all, each carbonic acid molecule can release one of its hydrogen ions to create a bicarbonate. This bicarbonate can further break down into a carbonate ion, releasing the other hydrogen ion. These hydrogen ions lower the pH of the water, making it more acidic. So how does this affect our coral reefs? Coral skeletons are formed from calcium carbonate in a process called calcification. Now remember those hydrogen ions from earlier? They combine with the carbonate ions in calcium carbonate to form bicarbonate. And here's the twist. Now, the available calcium carbonate in the water for coral's use is reduced because the carbonate half of the calcium carbonate molecule binds with the hydrogen ions instead of the calcium ions. This all results in an overall decreased calcification, or simply put, ocean acidification slows the growth of coral reefs.
But all the other stuff in the sea will probably be okay, right? Sadly not. For starters, corals aren't the only organisms that need calcium carbonate. Mollusks and echinoderms, shells and sea urchins to you and me, need it to build their shells and skeletons, as do less well-known animals such as foraminifera and bryozoans.
Okay, so ocean acidification is bad, really bad. But is there anything we can do? The one big, simple answer to that question is that we can stop burning fossil fuels. No fossil fuel emissions, no CO2 in the water. Except that's not such a simple answer. Otherwise, we would all be driving electric cars and watching Blue Planet on our solar-powered TVs. Alternative energy sources are available, with popularity and demand for renewable energies such as wind, solar, and geothermal power on the rise. But in the meantime, there are some imaginative management strategies being used to try to mitigate OA's effects, such as planting eelgrass beds to act as a carbon sink and lower carbon dioxide concentrations in the ocean.
Ocean acidification is happening across the globe, and what we really need is a shift away from fossil fuel use for a better, healthier, and less acidic ocean for generations to come.